Hi there, this is Ms. Page. In this lesson, which is the first lesson in Unit 6, which is on the vertex form or focuses on vertex form of quadratic functions, parabolas, we are going to look at taking the graph of a quadratic function and creating its function form. It's what we call its vertex form. You are familiar with vertex form. So we're looking at writing a quadratic function in vertex form from its graph. And you are familiar with vertex form because it's the same form that we use when we learned how to graph using transformations. And so it is the form that gives us the parameters of a, h, and k. So that is what we can see right here. So that I've highlighted in yellow, that is vertex form. And that is where what we've been using to identify A, which would be our 3, our H, which would be the opposite of that -2. So our H would be 2, and our K, which would be that minus or -5. What we also want to make sure we understand now is that the H and the K values together will always give us the coordinates of the vertex of the parabola. The vertex, remember, would either be the point where where the U-shape changes from increasing to decreasing. So here we would find our vertex here. This would be our H, which is 2, comma K, which is -5. That's what this point here would be. That's what this is saying. Another thing that we have previously learned and worked with is function notation and being able to use that to calculate values. So the 4 is a value of x, and so we would take our function f of x, and to find f of 4, remember, we would substitute the 4 in for the x, and then we would do the math following order of operations. So we would simplify, do the subtraction in the parentheses first. That would give us 2. Then we do the exponent, 2 squared would be 4. Then we do the multiplication, 4 times 3 is 12. And then we do the subtraction that was outside those parentheses, giving us that final value of 7. And that's a y value. Together, the 4 and the 7 are an x and a y. They are a point that is on the parabola. So understanding how all of that fits together is going to make today's problems very easy for you to finish. So this is written out in a step as far as how do we write a quadratic function in its vertex form. And we can use this strategy to write a quadratic function in vertex form from a graph like we're focusing on today, or from a table, or from a set of ordered pairs, that kind of a thing. And so we want to figure out what our vertex is. So we should be able to identify the coordinates of the vertex from the graph. And then that's our H and our K, and they go in here and here for our vertex form. We do have to make sure to do these problems that we understand the structure of our vertex form, where our A, H, and K are, where the X is, where the squared is, where the parentheses are, all of that, so that we get the final answer correct. Then what we need is another point that is on our graph. It can be any other point than the vertex, and we just call that one x, y. And those two numbers are going to be used for the x variable and the y variable, which is our f of x. And so at that point, we'll have numbers for h and k. We'll be using numbers for x and for y. And that will give us an equation that we can then do the math and solve for the a value of our function. And once we have that, then we can put it all together, the a, the h, and the k. The x and the f of x go back to being x and f of x, and we will have our final function in its vertex form. All right, let's apply that. So here our instructions tell us to write the vertex form of our function using this graph. So we have to understand the structure of vertex form. That's our f of x equals a times x minus h quantity squared plus k. And so the first thing I would do is figure out what the vertex is. So one of the things, of course, you want to make sure of is that you don't mix the points up, because then if you change the points around, like if you used 0, 14 for your vertex, your h and your k, that's not the same parabola. So our vertex is here, where our parabola changes from decreasing to increasing. And so the -5 would be our h value, and the -6 would be our k value. So here what we're looking at then is we know this much so far of our function. So we have f of x equals, we still don't know a, but we have x minus the h, which is -5, and that quantity is squared. Then we have our, you can either write it as plus -6 or just -6. We're going to, if you write it as plus -6, you're going to change it in just a minute anyway, so just go ahead and write it as -6. And then we're also going to have to simplify a minus a negative, because subtracting a negative is the same thing as adding a positive. So far we have f of x equals our a, this becomes x plus 5 quantity squared minus 6. So now what we have to figure out is what is the value of a. And this is where we need to realize that we need to find numbers to use for x and f of x, which is a y value. And we can do that by using a point, which would be an x and a y value on the parabola. So our x is 0 and our y is 14. So now f of x or y becomes 14. X becomes the 0. And here now we have to figure out what a is. So we start by, on the right hand side of this, using our order of operations to do the math. So the 0 plus 5 would become 5. That 5 is squared, so that's 25. That 25 is times a. So now what you have to realize you have is 14 equals 25a minus 6. Now you have a simple little algebra equation that you continue using your undoing algebra to solve for a. So undoing algebra is done in the reverse of order of operations. So we have to undo the subtraction first. Then we have to undo the multiplication. And now we have 1a or a, and the 20 over 25 has a common factor of 5, so it would reduce to 4/5, like so. And so now what we do to finish the problem is write the final vertex form using our new a value. So we have f of x equals 4/5 times in parentheses x plus 5 quantity squared minus 6, and there it is. All right, there's a practice problem here for you to try. There you go. So work through the problem. All right, let's take a look at it. So hopefully you started with using 0 for h and 50 for k, and that gave you this, which then you could have just simplified x minus 0 to just x. So if you wrote that as f of x equals a times x squared plus 50, that would be okay too. All right. And because notice that is actually what happens here at the end. And you drop the parentheses because there's nothing added or subtracted from the x. And so x squared does not need parentheses. So that's a little detail that you want to keep in mind in a problem like this. And then your other point, 218, that was given to you, the 2 had to be your x, the 18 your y, and then doing the math, you get 2 squared is 4, and then you would subtract the 50, and hopefully you have a negative here, and then dividing by the 4 gives you the -8. One thing I want to point out between these two problems that we've done is that you should have an idea about whether the a value will be positive or negative. Because if you know the parabola opens up, then you know there's no x-axis reflection, so a has to be a positive number. If you know your parabola opens down, then there is an x-axis reflection, which means a has to be a negative number. And so if you don't get a negative when you know you should, you can go back and find your mistake. If you get a negative when you know it should be positive, you can go back and find your mistake. All right, so now we're going to do the same thing, but we have some context. But the math itself does not change. It's just that when we're all done, our vertex form uses variables that are appropriate to the context. So that's the thing that I see most people make a mistake with here, is that they use x and f of x, and they should be using the variables that are in the context description. So we know that time is in a variable of t. And we know that height is in a variable of h of t. That's our function, the height of the ball. So height of the ball is h of t. And time, here shown in seconds, is t. It's a good idea to write those down so that visually you see them. Therefore, you can double check and make sure that is what you write at the end of your problem. So now we're going to start our process. And it's a good idea to write the structure of your vertex form, which will start with h of t, not f of x. Still have a. Inside, instead of x, you'll have t, because this variable and this variable need to match. Still have minus h, still have quantity squared, still have plus k. So we'll figure out our h and our k. This time we have to identify the coordinates, so pay attention to scale. So we see that we have a t value of 0.5. And we have an h of t value of 16. And I can figure that out because this is 15, 16, 17, 18, 19, and 20. So that's my h of t, or actually my k, sorry. They are t and h of t, but they're h and k for our vertex. So now what we have is h of t equals a times parentheses t minus our h of 0.5, quantity squared, plus our k of 16. All right, so now we need another point. You'll notice this time it's not given. So here are my recommendations for where to look for nice points. You don't want to pick a point that you have to estimate the values for. So no estimating of decimals unless absolutely necessary. And generally that's not going to be necessary. Somewhere there's a nice point. Like here's our y-intercept. It's a nice point. We can say that. We know that's 0, 12. This point across from it is nice. That's 1, 12. No estimating necessary. The zeros are pretty nice, usually. That's 1.5, 0. So we have 3 nice choice, all of which involve numbers that are positive or 0. No estimating is necessary. Doesn't matter which one you use. You can pick whichever one you think would be easiest to work with. So that's just something to keep in mind. So, given that we can choose, another point of these 3, and it doesn't really matter which one, is there a better choice? Maybe, maybe not. So it is to your advantage to kind of look ahead down the road and see what the math would be like. For example, you might be thinking that using the 0 and the 12, it would be nice. But do keep in mind that the 0 would be your t value, and 0 minus this decimal of 0.5 is going to give you a negative 0.5, and then you have to square that number. And then you got to deal with that decimal that results. Same thing happens if you use the t of 1, because 1 minus 0.5 is a positive 0.5, and then you have to square that decimal. And so the math there is a little bit more involved, but still doable, so it's not, if you're comfortable with that, then that's fine. If we choose to use this point here, our t value is 1.5. You might have been thinking, I want to use that one because it's a decimal. However, because h is also a decimal, 0.5, 1.5 minus 0.5 would be 1. And 1 squared is 1. And that's a very easy math to do in your head. So it's to your advantage to kind of think ahead what the math would be and see if there would be something that would be easier as you move forward in the problem. So I'm going to use this point here. So the 0 is my h of t. So 0 is our h of t. We're still got our a there. T is our 1.5. So using our order of operations here, 1.5 minus 0.5 is 1. That 1 is squared. 1 times 1 is 1. and 1 times a is a. So I have 0 equals a plus 16. And then subtracting the 16, I get a equals negative 16. And getting a negative a value, I should realize makes sense because my parabola opens down, and that means there is an x-axis reflection, and that would come from a negative a. So now what remains is to put it all together. So remember your structure, h of t equals our a value. We now use our negative 16 times in parentheses, t goes back to being t, minus the 0.5, still have the quantity squared, and still have the plus 16, and there is our vertex form for this context situation. All right, let's do another one together. So here, Adrian is building a homemade skate ramp, and he wants the model to model the shape as a parabola, but he sketches out a cross section shown below, so it's kind of like half of a parabola. And we're supposed to write the vertex form of this function. Notice it says h of capital L. So we have to realize that would be our y, which is here is representing the height of the ramp in feet. So this part would be h of capital L. One of the things about math, and this is true in science also, is that the case, uppercase, lowercase of your letters, your variables, cannot be changed. So you've got to use capital H, you've got to use capital L. And the moment that we see this is a capital L in the parentheses, that tells us length is a capital L. So these two match. So this one we would ignore. All right, because those two have to be the same. So now we need a vertex. You might be thinking, well, I don't see a vertex. So 10,6 is not the vertex in this case, and you'd be right. But, so what I want to explain about this is the way we're looking at this piece of a parabola, since it's only half of it, we are expected to assume it's starting here from the vertex of the origin, 0, 0. And so our vertex is the origin of 0, 0. So that's our h and our k. So structure, our h of L equals a times in parentheses, our capital L minus our h value of 0, quantity squared, plus our k value of 0. And then personally, I would simplify right now because I'm going to have to do that anyways. So L minus 0 is just L. So this becomes a times L squared. And anything plus 0 is itself. So this is just a times L squared. So that's what I have after I simplify all those zeros. So now I need another point because I got to figure out what the a is. And that's where I'd use my 10,6 here. So my 10 being like my x, that would be my L. So L is like my x. And 6, which is my y, that would be my h of L. So my h of L becomes 6 equals a times my L value of 10, and that 10 is squared. Parentheses optional. I just think it's clearer that, you know, the 10 is separated from the a, and only the 10 is squared, not the a if we put parentheses. So 10 squared is 10 times 10, which is 100. So now we have 6 equals a times 100, which we write as 100a. And then we would undo the multiplication. And then 6 and 100 have a common factor of 2. So reducing by 2, we get 3 over 50 for our a value. So now all that is left is to go back and write our vertex forms. Remember, h of L goes back to being h of L, both capitals. Now for a, we use our 3 over 50, which is positive, and that makes sense because the half of a parabola we have is opening up. Then we have our parentheses, and remember this variable here should match what's in your parentheses earlier. So this is capital L minus your h, which is 0, plus your k, quantity squared, plus your k, which is 0. Now I did this, but it's not actually necessary because, again, I'm going to get rid of those zeros. So really, I could have skipped that part if I realized this is just going to become L squared. So that is our vertex form. We don't want those zeros in the final vertex form. You'll notice you never see zeros in the problems we've done. We always just have to understand when we have a zero. Same thing here. All right. Here is a practice problem for you to try. Let's take a look. So hopefully, here is your vertex form, similar to the problem we just did, except this one, the half parabola does open down, so you should have expected a to be negative, and here it's a negative 16. All right, let's try another one. All right, let's take a look. So down here, this time, we have another negative 16. Interesting. And then we have we have an h and a k, though, that are not zeros. All right, closure. So here, Matthew thinks he can use the points 0, 11, and 4, 3 to write the vertex form of the quadratic function here that's shown in the graph. You are to respond, do you agree or disagree with Matthew, and explain your reasoning. So explain why you agree if you agree. So you would say, I agree because, or I agree with Matthew because, or you would say, I disagree with Matthew because, and then give your reasoning. Let's take a look at a possible response. So hopefully you disagreed with Matthew. And so that would be the correct response there. But your reasoning is your own wording, and it should be something similar to this as far as the concept is involved, but the wording could be different. So this says, I disagree with Matthew because neither of the points he wants to use are the vertex of the parabola. And the values of h and k in the vertex form have to be the coordinates of the vertex. So you might have said you disagree with Matthew because neither of those points is the vertex. He has to use the point 6, 2, because 6, 2 is the vertex. All right, that ends this lesson, and I hope you have a wonderful day.